In the wet dark of the South American rainforest, beneath a tangle of roots no light ever reaches, something is waiting. It is bigger than your hand. It has been sitting in the same spot for hours, maybe days, perfectly still. And yet, for all its size, for all the fear it carries, this animal has never, in all of recorded history, killed a single human being. That contradiction is the whole story. The largest spider on Earth wears the face of a nightmare and lives the life of a patient gardener. Tonight we go down into the burrow. We meet the giant hunters of the dark, what they are, how they kill, why they terrify us, and why almost everything you fear about them is wrong. Let's begin where the fear begins. Start with the body, because the body is the first thing that stops you. The Goliath bird-eater is the heaviest spider known to science, and the numbers are hard to hold in your head until you put them in your hand. A large adult weighs around 170 grams. That is roughly the weight of a young puppy. The weight of a billiard ball, the solid kind that cracks when it strikes another. Picture that mass, that density wrapped in dark bristled hair and standing on 8 legs. Its body alone, not counting the legs, stretches close to 5 inches, about the size of a closed human fist. Scientists place it in the genus Theraphosa, and they have measured these animals carefully, repeatedly, because the size invites disbelief. It is not a trick of a camera held too close. It is not a swollen specimen. This is simply how large a spider can grow when the rainforest gives it room and time. Most spiders you could miss with a glance. You could brush one off a sleeve and never break stride. Not this one. This one has presence. This one occupies space the way a small mammal does, and when it moves, you feel the movement register somewhere old in your brain, somewhere that knew long before you did that you should pay attention. Now stretch the legs out. From the tip of one leg to the tip of the leg opposite, a full-grown Goliath bird-eater spans up to about a foot, close to 30 centimeters at the extreme. Lay a human hand flat beside it, fingers spread as wide as they go, and the hand loses. The spider is wider. Set it on a dinner plate, and the legs reach the rim on every side. There is a second giant worth naming here, because it explains a quirk of the record books. The giant huntsman spider has an even longer leg span. Its thin legs reach slightly farther, but the huntsman is built like a sprinter, light and spindly. The Goliath is built like a heavyweight. Pound for pound, leg for leg, nothing carries more spider in one frame. Up close in a slow, wide shot, you notice the legs are not smooth. The third and fourth pairs carry small spines, and the whole animal is sheathed in fine hair that catches the light a dull reddish brown. That hair is not decoration. We will come back to what it does. For now, just hold the scale in your mind. A spider the width of a place setting at your dinner table. A spider you would not pick up. A spider that, frankly, looks like it could pick up something of its own. Under the front of that body fold the fangs. And the fangs are the part the size was preparing you for. A Goliath bird-eater's fangs reach up to nearly 1.5 inches in the largest individuals, 2, sometimes close to 4 centimeters of curved, hardened weaponry. They are long enough easily to break human skin. Here is the detail that matters, the detail that changes how you picture the strike. A tarantula's fangs fold underneath its body, pointing back toward itself like the blade of a switchblade tucked into the handle. That geometry means it cannot bite sideways the way a dog snaps. To drive those fangs into anything, it must rear up and strike downward, lifting the front of its body and bringing the fangs straight down like a pair of parallel daggers. Watch it happen, and the motion is unmistakable. The front legs lift, the body tilts back, and then the whole weight of the animal comes forward and down in a single committed motion. There is nothing tentative in it. The strike is the period at the end of a very long, very patient sentence. Those fangs are not for show, and they are not weak. The bite of a large tarantula can punch clean through a human fingernail, through the hard keratin plate, not just the soft skin around it. In the wild, that same force drives through the shell of a beetle, the hide of a small lizard, the skin of a frog. The fangs work like 2 hypodermic needles, and as they sink in, they deliver. Each fang is fed by a venom gland tucked behind it, and the puncture and the injection happen as one event. For a human, the mechanical part of that bite, the sheer puncture, is often the worst of it. Imagine two thick needles driven downward by an animal, the weight of a billiard ball. That is a wound you would not forget. And yet here the story takes its first hard turn, the turn we will keep returning to. For all that force, for all that machinery, the Goliath bird-eater frequently delivers what keepers call a dry bite. Fangs in no venom released. It controls the venom. It decides. The weapon is fully loaded, and the animal most of the time chooses not to fire. So what is the venom actually for? Not for us. This is the thing people get backward. The venom of a tarantula did not evolve to kill the things that frighten us. It evolved to subdue and break down the things it eats. It is a hunting tool, and a digestive one, tuned over millions of years to insects and small prey, not to a creature our size. In a lab, that venom is genuinely lethal to mice. To an insect, it is catastrophic. To you, in the overwhelming majority of cases, a Goliath bird-eater bite lands somewhere around the pain of a wasp sting, sharp, memorable, but not a threat to your life. The mismatch is the whole point. We look at the size, the fangs, the hair, and our nervous system fills in a danger that the chemistry simply does not support. The animal is built to be terrifying to a cricket. We just happen to be standing in the cricket's place when we look at it. When it does commit to prey, the strike is a single locking motion. The fangs drive down and in, and they hold. This is not a snake that bites and retreats to wait. The tarantula seizes pins the prey beneath the front of its body and keeps the fangs buried while the venom goes to work. Up close, you would see the prey's struggle slow and then stop. The grip does not loosen. There is a patience even here in the kill itself, a willingness to simply hold on longer than the prey can fight until the fight is over. And then comes the part that is harder to watch. The tarantula does not tear its food apart. It cannot. It has no jaws for chewing. Instead, it begins to flood the prey with digestive fluid, breaking the body down from the inside while the spider holds it close. We will come back to that. For now, hold the image of the grip. Fangs down, weight forward, no release. All of this happens in the dark, and the dark is not an accident. The Goliath bird-eater is a creature of the night, and the burrow a hunter that does its work when the rainforest goes black and most eyes go useless. It spends its days deep in a silk-lined tunnel under the roots and the leaf litter, and it emerges into a world where sight barely matters. For the small animals moving across the forest floor at night, the frogs, the insects, the occasional unlucky rodent, this means the danger arrives without a silhouette. Nothing rears up against the moon. There is no shape to flee from. The hunter is simply there, at the mouth of its tunnel, or just outside it in a darkness so complete that seeing the spider was never an option. By the time anything small enough is close enough to matter, the encounter is already decided. If it cannot see in that dark, how does it hunt? Through the ground. A tarantula reads the world as vibration, and it reads it with extraordinary care. Tiny sensory hairs covering its legs and body pick up the faintest tremor in the soil and the air, the footfall of an insect, the hop of a frog, the scrabble of something passing too close to the burrow. Stand close enough, in the silence of the forest floor, and you would hear nothing at all. The spider, meanwhile, is hearing everything, not with ears but with its skin, with a body wired to feel a footstep before its owner ever arrives. It is the reason ambush works. The spider does not need to chase what it can feel coming. It only needs to wait in the right spot, legs resting lightly against the earth, reading the ground like a tightened drum, and to know from the size and rhythm of the tremor the difference between a meal, a mate, and a threat. And when the tremor says meal, the wait ends all at once. The lunge out of the burrow is fast, far faster than the slow, heavy creature you have been picturing. An animal that can sit motionless for days covers the final distance to its prey in a fraction of a second. The front legs and fangs committing before the prey's own nervous system has finished registering the danger. From above, in the dark, the motion would read as a single dark blur out of a darker hole. There is no run-up. There is no chase across open ground. There is the stillness, total and patient, and then there is the strike. And the stillness is simply gone, replaced by an animal that has already won. That is the rhythm of this hunter's entire life. Long, long nothing. Then everything at once. Then nothing again. Consider what ends up dragged into that burrow. The name says bird eater, and the name oversells it, but only a little. The truth is almost stranger. This spider is an opportunist, and its menu is governed by one rule. Anything smaller than itself is potentially food. In the wild, biologists have watched the Goliath bird eater take earthworms and beetles, frogs and toads, lizards and bats. It eats mice. It eats rodents larger than you would guess. And it eats snakes. Small ones, yes, but snake's an animal most people file under predator, not prey. Picture the reversal. A young snake moving through the leaf litter, a hunter in its own right, suddenly seized and held by something with 8 legs and a downward strike. The bird part of the name is the rarest item on the list, the exception rather than the rule born from a single old engraving of a different tarantula taking a hummingbird. The everyday reality needs no exaggeration. A spider that hunts vertebrates, animals with spines, with skulls, with their own ambitions is remarkable enough without the birds. It sits at a strange seam in the food web, an invertebrate that routinely eats things we think of as the animals that eat invertebrates. Not every giant hunts the same way, and not every giant is so reluctant to bite. Travel from the rainforests of South America to the dry burrows of Kenya and Tanzania, and you meet a very different temperament. The king baboon tarantula, Pelanobius muticus. Where the Goliath is large and largely defensive, the king baboon is fawn-coloured, deep-digging, and famously short on patience. This is an old-world tarantula, and old-world species carry a reputation. New-world giants do not, faster to anger, quicker to strike, and armed with venom that means business. The king baboon will not always bother with a warning. It can rear and bite with a speed that surprises even experienced keepers, and the bite is no wasp sting. Documented envenomations describe severe pain, swelling, and muscle cramping that radiates up the bitten limb. One case even recorded a hallucinatory episode. Researchers studying its venom have found a peptide that hits multiple pain pathways at once. A chemistry evolved not to kill a large attacker, but to flood it with so much agony that it never tries again. No human has died from one, but the king baboon makes a point the Goliath softens. Within this family, temperament is not uniform. Some giants would rather hiss and hide. Some would simply rather bite. Return to the burrow itself, because the burrow is part of the weapon. A Goliath bird-eater does not wander the forest in search of food. It engineers a fixed position and lets the food come to it. The burrow is a tunnel dug beneath a rock or a tree root lined with silk, often in the marshy upland ground these spiders favour. From the prey's side, the geometry is merciless. The mouth of the tunnel is an invitation, a dark, sheltered space that small animals are drawn toward by instinct, looking for exactly the cover the spider is offering. But the tunnel narrows, and at the narrow end waits the thing that dug it. What looks like shelter is a funnel easy to enter and very hard to leave. The spider does not even need to give chase. It has shaped the ground so that the chase is unnecessary, so that the simple act of seeking safety carries an animal directly into reach. From above, in a wide shot of the forest floor, the burrow is nothing, a hole among roots, a shadow. You would step over it without a thought. The animals that live at that scale do not have the luxury of stepping over it. There is mercifully a warning, but you have to be in the wrong place to hear it. When a Goliath bird-eater feels cornered before it ever considers the fangs, it makes a sound. It rubs the bristles on its front legs and pedipalps together in a motion called stridulation, the same mechanical trick a cricket uses to chirp, and the result is a hiss loud enough to be heard from up to 15 feet away. 15 feet. For a spider, that is an extraordinary volume, a sound that carries across a small room, produced by an animal with no voice, no lungs in the way we mean it, nothing but hair against hair. People who have heard it compare the texture to the rip of Velcro pulling apart. It is not a bluff in the way a harmless animal bluffs. It is an honest advertisement paired with everything the spider can back it up with. The hiss says plainly that you have come too close, and that the things waiting behind the hiss are worse. Most predators in the rainforest have learned to take the warnings seriously. The hiss exists precisely so the spider rarely has to do anything more. If the hiss does not move you, the spider reaches for a weapon that needs no fangs at all, and it is for a human the part you should actually respect. The Goliath bird-eater's abdomen is carpeted in uticating hairs, tiny barbed bristles, and when threatened it rubs its hind legs briskly against its own body and flings a cloud of them into the air at the attacker. These are not ordinary hairs. They are microscopic harpoons shaped to catch and embed. Drifting into the eyes, the skin, the lining of the nose and throat, they lodge and they itch and they burn, and the irritation can persist for days. Against a small predator, they can be lethal outright. A mouse that inhales a faceful may not survive it. Against a human here is the quiet truth that runs counter to the whole fearsome image. A severe allergic reaction to these hairs is more likely to send you to a doctor than the venom in the fangs ever will. The spider's most reliable defense is not the bite everyone fears. It is a cloud of barbed hair it throws from its own back, a weapon it deploys without ever making contact at all. And if every warning fails, the body itself becomes the final threat display. A cornered Goliath bird-eater rears up, lifting the front of its body high, raising its front legs into the air, tilting back until the fangs are bared and pointing forward at whatever will not leave. It is making itself larger. It is turning a horizontal animal into a vertical wall of legs and fangs, and the message could not be clearer. Coatis, the long-nosed raccoon-like predators that hunt these spiders, are exactly the audience this display is built for. Up close in that reared posture, you see the whole arsenal at once, the fangs unfolded from beneath the body, the front legs spread wide, the abdomen ready to release its hairs. This is the spider holding nothing back. Every defense stacked into one posture. Everything before this was a request. This is the ultimatum. And notice the order of it all: hiss, first, then hairs, then this final rearing threat, and only after all of that, the bite. An animal we cast as a mindless killer is in practice an animal that asks 3 times before it strikes. That order matters because it dismantles the oldest assumption we make about these spiders. We assume aggression. We see the size and the fangs and we fill in a creature looking for a fight. The behavior says the opposite. The Goliath bird-eater, and most tarantulas with it, are defensive rather than aggressive animals whose entire strategy is built around avoiding the confrontation, not seeking it. The hiss, the hairs, the rearing display, every one of these is a way to end an encounter without a bite, because the bite costs the spider something it would rather keep. Some of that instinct is wired even deeper in us. Primates, including humans, appear to carry an innate readiness to fear spiders and snakes, a bias that shows up early and strong, sharpened over millions of years, in which the small venomous thing in the leaves was worth flinching from first and questioning later. So the fear is not irrational. It kept our ancestors alive. But it is calibrated for a world of many dangerous small animals, and it fires just as hard at the giant that for all its size would genuinely rather you simply walked away. So here is the number the entire reputation rests on, and it is not the number you expect. In all of recorded medical history, there is not a single confirmed human death from a tarantula bite. Not one. Not from the Goliath bird-eater, not from the king baboon, not from any of the more than 850 known tarantula species, not the largest, not the most ill-tempered, not the most potent. The venom that kills laboratory mice, that liquefies insects, that drops a frog in seconds, has never once killed a person. The records bear it out plainly. In a recent year, American poison control centers logged only 44 tarantula exposures, and of those just 17 needed any medical evaluation at all, almost all of them minor, almost all of them pet-related. Set that against the image we have built. The dinner plate body, the inch-long fangs, the downward strike, the snakes dragged into the dark. All of it true. And the body count after centuries of humans and tarantulas sharing the same forests and fields and now the same living rooms stands at 0. The most frightening-looking spider on Earth has a kill record against humans that is simply stubbornly empty, which makes the real horror story the one we never tell, the one where we are the danger. Because these giants do not stay safely in the deep rainforest apart from us. The king baboon digs its burrows in the dry ground of East Africa, in the same regions people farm and walk. Tarantulas of one species or another turn up in fields, in walls, in the dark corners of homes, in woodpiles and in the stories every keeper knows, occasionally in a boot left out overnight. We share the ground with them, far more than we admit. And in nearly every one of those encounters, the spider's preference is the same one: it has always had to be left alone, to retreat into the dark, to avoid the enormous, frightening animal looming over it. The genuine tragedy of the tarantula is not what it does to us in the night. It is how completely we have inverted the truth, casting the patient, defensive, harmless giant as the monster, while it sits in its burrow, wanting nothing from us at all, the most feared hunter in the room, and the one with the least reason to be feared. Before we leave the fear behind, one more measurement, because the record itself has a story. The largest verified Goliath bird-eaters reach a leg span of close to a foot, and one specimen, raised and measured carefully, is often sighted near 11 inches across, the kind of size that turns a scientific figure into a held breath. There is a famous photograph taken by a researcher in Guyana of one of these spiders carried out of the rainforest, and the thing people remember is not the legs, but the sound it made walking. Its feet hardened at the tips, clicked against the forest floor, like a horse's hooves on a hard road. Sit with that. A spider heavy enough, large enough, that you hear it approach before you see it, the footsteps of an animal that has no business making footsteps at all. The leg span record technically belongs to the slender giant huntsman, whose thin legs reach a touch farther. But the huntsman makes no sound you would notice. The Goliath does. And in the dark of its home forest, that small detail is the difference between a spider and a presence, between something you find and something that arrives. And so the dread resolves into its truest shape, which is not speed and not venom, but time. The deadliest thing about this hunter is its patience. A Goliath bird-eater can sit in a single spot, motionless for hours that stretch into days, asking nothing of the world but that something small eventually pass within reach. It does not tire of waiting. It does not grow restless and abandon the post. Its whole metabolism is built around the long stillness, a slow heart, a slow burn, a body that can do almost nothing for almost forever. The prey, by contrast, cannot wait. It must move. It must forage, drink, cross open ground, seek the shelter of a dark and inviting tunnel. Every living thing the spider hunts is governed by needs the spider has learned to outlast. That is the real weapon, the one beneath the fangs and the hairs and the size. Not the strike which is over in a heartbeat. The wait that comes before it, hours of perfect predatory nothing against prey that does not have hours to give. The hunter that simply outlasts everything it eats. Now turn the animal over and look at how it is built, because the closer you look, the stranger it gets. Start with the eyes. A tarantula has 8 of them, a cluster of small dark lenses set on a little mound atop its head, arranged in 2 rows. 8 eyes, and it is still nearly blind. Those eyes resolve little more than light from dark movement, from stillness, the broad shape of the world in low contrast. They cannot build the sharp, detailed picture your 2 eyes are assembling right now. Sit with the wrongness of that. 8 eyes is a number that suggests overwhelming vision, a creature that sees in every direction at once, that misses nothing. The reality is the opposite, an animal that carries 8 eyes and barely uses them, that lives most of its life in darkness, where vision would be useless anyway. Evolution gave it the lenses, and then, finding them beside the point, simply stopped investing in them. The Goliath bird-eater navigates a world its eyes can hardly report. The eyes are almost a vestige, a leftover. Whatever this spider knows about its surroundings, it is not learning through the 8 dark eyes watching you back. If not through sight, then how? Through touch, through hair. A tarantula does not so much see the world as feel it, and it feels it across nearly its entire body. The legs, the abdomen, the head are covered in fine sensory hairs, and those hairs are the spider's real window onto its surroundings. Some read the faint currents of air a moving animal pushes ahead of itself. Some read vibration in whatever the spider is standing on. Together they assemble something we have no direct word for, a picture built not of lump but of trembling, a map of the immediate world drawn in pressure and motion. Imagine for a moment navigating your home in total darkness, knowing where everything is, not by looking but by feeling the air shift as you neared each wall. That is closer to the tarantula's daily experience than anything your eyes do. Up close, those hairs look like simple fuzz, the bristled coat of a large spider. They are nothing of the kind. They are thousands of separate sensors, each one feeding the animal a thread of information, all of it woven into a sense of the world that is vivid and detailed and almost entirely silent to us. Some of those hairs are tuned so finely they function almost like a sense of hearing without an ear anywhere in the body. Specialized sensory hairs can detect vibrations of astonishing subtlety, the faint mechanical tremors that travel through the ground and the air when anything moves nearby. To the spider, a beetle's footstep, the landing of a fly, the approach of a larger animal, each arrive as a distinct signature, a pattern in the trembling that means something specific. It is reading vibration the way you read a voice, pulling identity and intention out of a medium most creatures barely notice. This is how an ambush works in total darkness. The spider does not need to see the prey coming, because it can feel it coming. It can tell from the rhythm and weight of the tremor roughly what is out there and roughly how big. There is a kind of language being spoken across the floor of the rainforest at all times, written in vibration, and the tarantula is fluent in it. It has spent millions of years learning to listen with its skin to a world it can barely see, and in that world the listening is enough. Now the strangest weapon in the whole arsenal, the one that turns the spider's own body into a defense. Most New World tarantulas, the Goliath among them, carry urticating hairs on the abdomen, and unlike ordinary hairs, these are barbed, built to be shed and flung. When a threat looms, the spider does something almost no other animal does. It reaches back with its hind legs, brushes briskly against its own abdomen, and casts a cloud of these hairs off its body and into the air toward the attacker. Read that again, because it is genuinely uncanny. The animal is throwing pieces of itself as a projectile defense. It is deliberately bald patches on some old spider's abdomens, worn smooth from repeated use the way a much-fired tool wears down. No teeth, no claws, no venom required. Just a part of its own body manufactured to be detachable, aimed and released into the eyes and airways of whatever has come too close. There is something profoundly alien in the strategy, a defense with no real parallel among the animals we know best. The tarantula does not only carry a weapon, the tarantula sheds its weapon by the thousand from its own back. And those shed hairs do real damage, which is why the strategy survives. Each urticating hair is microscopically barbed, shaped like a tiny harpoon built to catch in soft tissue and stay. Drifting into an attacker's eyes, settling on the thin skin of the face, drawn into the nose and throat and lungs, they lodge and they inflame. The irritation is not a brief sting. It can persist for days, an itch and a burn that no scratching reaches because the cause is embedded beneath the surface. Against a small predator, the effect can be severe enough to kill a mouse, with a faceful of these hairs may not survive the encounter. Against a human, the hairs are the part of the tarantula that most often sends someone to a doctor more reliably than the bite ever does. People who keep these spiders learn to wear gloves and keep the animal away from their faces because a cloud of urticating hairs in the eyes is a genuine medical event. Here again, the reputation has it backward. The fangs are the famous threat, but the quiet drifting hairs, invisible barbed thrown from across a gap, are the defense you actually have to respect. Now, open the body and the wrongness goes all the way to the blood. A tarantula's blood is not red, it is blue. Where our blood carries oxygen on hemoglobin, a protein built around iron that flushes red when it binds. Oxygen, the tarantula uses a different molecule entirely, hemocyanin built around copper instead. And copper, when it takes up oxygen, does not turn red. It turns blue. So the fluid moving through this animal runs a faint sulfur blue, a color we instinctively read as wrong for something alive. Stranger still, it is not really blood in our sense at all. It has no vessels carrying it in a closed loop, no red cells, nothing enclosed. The fluid called hemolymph simply fills the body's open interior, bathing the organs directly, sloshing through the whole internal space rather than running through dedicated pipes. And there is one more thing about that blue fluid, a detail that loops back to the fear introduced into a small mammal tarantula. Hemolymph can be toxic in its own right. The animal is built so differently from us that even its blood, the most basic substance of its life, is a color we don't trust and a chemistry that doesn't quite play by our rules. That blue blood is fed by lungs unlike anything in your chest. A tarantula breathes through what are called book lungs, and the name is exact. Inside the lower abdomen sit stacked plates of thin tissue, 15 or more folded sheets layered against one another like the pages of a book held slightly ajar. Air seeps in through small slits on the underside of the abdomen, slips between the pages, and the blue hemolymph flowing through each plate takes up oxygen across that vast folded surface. A Goliath bird-eater carries 2 pairs of these book lungs, and the total surface for gas exchange unfolded is startling for an animal this size. But here is the part that unsettles: there is no active breathing. No diaphragm, no rhythmic rise and fall, no breath as you would recognize it. The air simply diffuses in and out passively through slits that can narrow but never fully close. The spider does not inhale. It simply leaves the pages of its lungs open to the air and lets the oxygen find its own way in. A creature that breathes without ever taking a breath, sitting in its burrow perfectly still, the pages of its body quietly open to the dark. Everything we have described so far hangs on a frame turned inside out. A tarantula wears its skeleton on the outside. There are no bones anywhere within it. Instead, the entire soft body is sealed inside a rigid outer shell called an exoskeleton, a casing of cuticle made from chitin and protein, layered like the grain in plywood. That shell is the spider's armor, its anchor for muscle, and its barrier against drying out all at once. But it carries one harsh limitation that shapes the whole of the animal's life: it cannot grow. Your skeleton lengthens with you year by year, quietly keeping pace. The tarantula's cannot. The shell that protects it is also a cage that fits only for a while, and the spider inside keeps growing while its armor stays exactly the same size. Sit with that bind. To get larger, this animal cannot simply expand. It must build an entire new body beneath the old one, then break out of itself and leave the old shell behind an empty husk that looks unnervingly like a second spider. The exoskeleton is the reason for one of the strangest events in the natural world. We are about to watch the spider climb out of its own skeleton. But first, the legs, because the way a tarantula moves is quietly impossible by our standards. Your limbs work in opposed pairs of muscles, one set to bend the joint, another set to straighten it back out. A tarantula is missing half of that system. It has muscles to pull its legs inward to flex them, but for many of the leg joints it has no muscles at all to push them back out. So, how does an 8-legged animal extend a single step? Hydraulics. The spider pumps its own blue blood under pressure into the legs, and the fluid pressure itself forces the joints to straighten. Every stride is a small hydraulic event. Flex by muscle, extend by pressure. Flex by muscle, extend by pressure. 8 legs of it coordinated, fluid driven into limb after limb to walk across the forest floor. It is closer to how a hydraulic excavator moves its arm than to how you move yours. The spider does not simply walk. It pressurizes itself into each step, working a pump where you would use a muscle running its whole body, its whole motion on the controlled flow of the blood inside it. And that single strange fact explains an image everyone has seen, and few understand: the curled-up dead spider. Picture it: a spider on its back legs drawn tightly inward over its body, that unmistakable shape of a thing that has died. Now you know why it happens, and the reason is purely mechanical, almost sad in its logic. Those legs extend only because blood pressure pushes them out. The only muscles are the ones that pull them in. So when a spider dies, the heart stops. The pressure that held the legs open drains away, and with nothing left to oppose them, the flexor muscles draw the legs inward and hold them there. The curl is not the spider clenching in a final agony. It is the opposite. It is the body going slack, the hydraulics failing, the legs falling into the only position left when the pressure is gone. The same physics shows up in life too. A tarantula, too dehydrated to maintain its internal pressure, can't push its own legs out and begins to curl, a keeper's quiet warning sign. The curled spider is not a spider that tensed. It is a spider that lost the pressure that kept it standing. Return to the fangs and notice how they sit when they are not in use. A tarantula's fangs do not jut out like a snake's. They fold, pivoting down and back underneath the front of the body, tucked away along the underside like the blade of a switchblade closed into its handle. This is the mark of the whole infraorder. These spiders belong to fangs that move parallel to the body's long axis, pointing backward at rest rather than crossing toward each other like the fangs of most smaller, more familiar spiders. The arrangement is exactly why the Goliath bird-eater must strike the way it does. With fangs that fold downward and back, it cannot bite across a target. It has to rear up and drive straight down, hammering the fangs into prey from above, using the lift of its own body to power the blow. So, the famous downward strike is not a stylistic choice. It is dictated by the architecture of the mouth, a folding switchblade geometry that means this animal can only deliver its bite one way up and then down with everything it has. Behind those folding fangs sits a mouth that has never chewed a single thing in its life. A tarantula cannot chew. It has no jaws built to grind, no teeth to break food into pieces, no way to take a bite in the sense you mean the word. What it has instead is a sucking stomach, a muscular tube running through the front of its body that works like a powerful pump. When those stomach muscles contract, they widen the tube and create fierce suction, drawing food up through the mouth as liquid. That is the only way a tarantula can eat it, can drink and only drink. Solid food is to this animal simply unavailable. A chunk of anything is as useless to it as a meal sealed behind glass. Everything it consumes must arrive already liquefied, thin enough to be pulled up through that narrow, sucking throat. It sets up the obvious problem. The spider hunts solid living prey, animals with bones and shells and skin, and yet it can only swallow liquid. Something has to bridge that gap. Something has to turn a frog, a beetle, a mouse into something drinkable. And the way the tarantula solves it is the most unsettling part of the whole body. It digests its prey outside its own body. This is the resolution to the riddle of the sucking stomach, and it is worth picturing fully. When a tarantula catches prey, it does not swallow it. It holds the animal close and floods it with digestive juices from its own gut, spilling enzymes over and into the body of its meal, and those enzymes begin to dissolve the prey from the inside out, breaking flesh down into liquid while the spider simply waits gripping as its food turns to broth. The digestion happens out in the open on the prey's own body before a single drop is ever consumed. Only once the inside of the animal has been rendered down does the sucking stomach go to work drawing up the liquefied remains and leaving behind a small, dry, discarded husk, the emptied shell of whatever it ate, balled up and cast aside. Stand close enough at the mouth of the burrow, and what you would find afterward is not bones picked clean, but a crumpled hollow shape, the prey turned inside out and drunk dry. The tarantula does not eat its food so much as melt it, then drink it. The horror here is not violence, it is patience and chemistry. Step back and take in the whole strange blueprint at once. A tarantula's body comes in two parts, and only two. The front section, the cephalothorax, fuses the head and chest into a single unit, carrying the eyes, the fangs, the brain, the sucking stomach, and the bases of all 8 legs. The rear section, the abdomen, holds the heart, the book, lungs, the gut, the silk glands, and the urticating hairs. A narrow waist connects them, and that is the entire architecture. 2 segments, 8 legs, no bones, no internal skeleton, no spine, no skull. Compare that to your own body with its hundreds of bones and its single great cavity of organs, and the tarantula reads almost like a different solution to the same problem of being alive. A design that arrived at animal by an entirely separate road. Everything we have walked through hangs on this frame. The blue blood fills the open space between these 2 segments. The hydraulic legs run on the pressure inside them. The whole creature is a sealed soft body in a hard shell, divided in 2, running on fluid. It is not a smaller, simpler version of anything familiar. It is its own complete and ancient idea of what a body can be. Look once more behind the fangs at the machinery that loads them. The fangs are mounted on a pair of stout appendages called chelicerae, the heavy articulated bases that swing the fangs and drive them downward. And coiled inside, feeding each fang, sit the venom glands. When the spider strikes and the fangs sink in, muscles squeeze those glands, and venom travels down a fine internal channel to the fang's tip and out into the wound. The whole apparatus, working as one motion, seize and inject in a single committed strike. But recall the detail from the dread, the one that complicates the menace, the spider controls that squeeze. It can drive the fangs home and release nothing at all, the dry bite, because venom is metabolically expensive, costly to manufacture, and worth conserving for prey rather than wasting on a threat too large to eat. So the chelicerae and their hidden glands are not a hair trigger. They are a deliberate system, a loaded weapon with a careful hand on the safety. The most fearsome part of the spider's anatomy turns out to be in its everyday use the most restrained. And at the far end of the body, the tarantula carries a workshop. Nothing in our anatomy resembles it. Spins silk from the tip of its abdomen. Set on the underside near the rear are small finger-like organs called spinnerets, flexible mobile nozzles connected to silk glands inside the body. The silk begins as a liquid protein within the spider and is drawn out through these spinnerets. And in the very act of being pulled and stretched, it transforms, hardening from fluid into thread as it leaves the body. The spider is, in the most literal sense, manufacturing fiber on demand, extruding it live from its own back, controlling the spinnerets to direct where the thread goes. A Goliath bird-eater does not weave the great aerial webs people picture when they think of spiders. It uses its silk closer to home to line the walls of its burrow, to lay down trip lines, to wrap and to signal. But the machinery is the same wonder either way, a living creature with built-in spinning organs turning liquid into thread at the moment of use. We will follow that silk next, out of the strangeness of the body and into the surprising intelligence of how this animal uses what it builds. Look at the front of the spider and you'll count what seem to be 10 legs. There are only 8. The extra pair set just ahead of the true legs, and flanking the mouth are the pedipalps, shorter leg-like appendages that have been repurposed into something closer to hands and sensors. The tarantula uses them to handle and position food at its mouth, to feel its way through tight spaces, and to read chemical signals from the world around it. In mature males, the pedipalps take on a second, entirely separate role in reproduction. But for the everyday business of living, they are tools, the spider's manipulators and probes, constantly in motion at the leading edge of the body. Watch a tarantula examine something unfamiliar, and you'll see the pedipalps go first, tapping and touching ahead of the fangs, gathering information before the animal commits. They are limbs that evolution pulled off the job of walking and reassigned to the job of knowing. The spider effectively has a dedicated pair of sensing appendages mounted right beside its mouth, a front line of touch and taste, feeling out the world a half step before the rest of the body arrives. And here the strangeness reaches its quiet peak. A tarantula tastes the world through its feet. Scattered across the tips of its legs and pedipalps are contact chemoreceptors, sensory structures that respond to chemical cues the moment they touch a surface. When the spider sets a foot down, it is not only feeling the ground, it is sampling it, reading the chemistry of whatever it stands on, detecting the scent trail of prey, the lingering pheromone of another tarantula, the chemical identity of the surface itself. The scents we keep locked inside a wet mouth, the tarantula has spread across the soles of all 8 legs. Think about what that means for how it moves through the world. Every step is a taste. To walk across a patch of ground is to read it, to know through the feet alone who passed this way, whether food is near, whether a mate or a rival has left a chemical signature in the soil. The spider does not need to bring the world to its mouth to know it. It knows the world simply by standing on it, tasting every surface it touches, learning its surroundings one footfall at a time. For all this machinery, the tasting feet, the listening hairs, the pressurized legs, the engine that runs it idles astonishingly low. A tarantula's metabolism is slow, its heartbeat unhurried, its whole physiology tuned for stillness. This is an animal built to do almost nothing for very long stretches, and to pay almost nothing for the privilege. Its body burns fuel at a rate that would leave a mammal of similar size starving, where a small, warm-blooded creature must eat constantly just to hold its temperature. The tarantula simply sits cool and quiet, its slow heart pushing blue blood through an open body at a pace that matches its patient life. This is the physiological secret beneath the deadly patience we met in the dread. The spider can outwait its prey for days, not through willpower but through chemistry, a metabolism so frugal that doing nothing costs it almost nothing. The long stillness in the burrow is not endurance. It is the animal's natural resting state, a body designed to spend as little as possible while it waits for the world to deliver a meal. The slow heart is the whole strategy, beating quietly at the center of a creature that has made patience into a way of being. Step back from all of it and one fact settles over the whole body like a held note. Almost none of this is new. The tarantula's design, the exoskeleton, the book lungs, the 8 legs, the hydraulic movement, the blue blood, is ancient. A body plan that has worked so well, it has barely needed to change across an almost unimaginable stretch of time. The book lung alone appears in the fossil record in forms close to 400 million years old, structures preserved in ancient stone that are nearly indistinguishable from the lungs inside a living tarantula tonight. This is not a creature still being refined by evolution, still searching for a workable shape. It is a creature that found its answer long ago and has been living inside that answer ever since, while the world above it filled with dinosaurs and then emptied of them while continents drifted and climates turned over and over. Everything that feels alien about this body is alien, partly because it is so old, a design from a deeper chapter of life on Earth, carried forward almost unchanged into ours. We are not looking at something strange and new. We are looking at something strange and very, very old, still walking the forest floor on the same blueprint it has used since before the dinosaurs drew breath. That ancient body is also a builder, and here the story turns from strangeness to skill. A Goliath bird-eater's burrow is not a hole it happened to find. It is a structure. It engineers a tunnel dug into the earth, and then lined throughout with silk, the spinnerets laying down a smooth interior skin along the walls. That silk lining is doing real work. It reinforces the burrow against collapse, helps regulate the humidity inside, and turns loose soil into a stable, sheltered chamber the spider can return to for years. In the damp upland forests, these spiders favor holding a burrow open and habitable is no small feat, and the silk is the engineering that makes it possible. Look at what that represents. An animal we have been describing as a patient lump of instinct is in fact a maker selecting a site, excavating a tunnel, and then finishing the interior with material it manufactures from its own body. The burrow is architecture, purpose-built and silk-reinforced, a home and a hunting blind and a fortress in one. The awe of this animal begins here, at the realization that it does not merely occupy the world, it constructs the small piece of the world it lives in, and the burrow is wired. Reaching out from its mouth, many tarantulas lay down lines of silk across the surrounding ground trip lines, radiating from the entrance like the threads of a tripwire alarm. These strands are not for catching prey directly, they are for information. Each line carries vibration, and the spider resting at the burrow's mouth with its legs in contact with the silk. You can feel the faintest tug or tremor travel down a thread the instant anything touches it. An insect crossing a line, a small animal brushing against it, the disturbance runs along the silk straight back to the waiting spider, telling it that something has entered the perimeter and roughly where. It is an early warning system built from the animal's own thread, extending the spider's sense of touch out across a wide circle of ground it could never feel directly. Picture it from above, a dark burrow mouth, and around it an invisible web of single strands laid across the leaf litter, each one a nerve running back to the hunter at the center. The tarantula has effectively enlarged itself, turned the patch of forest around its door into an extension of its own body, every silk line a tripwire reporting back in the language of vibration. What makes those trip lines remarkable is not that the spider feels them, but that it reads them. A vibration on the silk is not simply an alarm, it is information, and the tarantula interprets it. From the strength, the rhythm, and the character of the tremor traveling down a thread, the spider draws distinctions that decide its next move. Is this prey, small and edible, worth the lunge? Is it a threat large and dangerous, better met with stillness, or a defensive display? Is it in the right season, a potential mate signaling at the edge of the burrow? The same silk line carries all these possibilities, and the spider sorts them by the signature of the vibration alone in the dark, without ever seeing what made it. Researchers studying tarantula sensing describe a system finely tuned to these substrate vibrations, an animal making real decisions from mechanical signals most creatures couldn't even detect. It is a kind of reading a hunter, pulling meaning out of the trembling of a thread and choosing correctly again and again whether to strike, to hide, or to court. The intelligence of this spider is not loud. It lives in exactly this, the quiet, accurate interpretation of a world delivered entirely as vibration. And then comes the part that is hardest to film and easiest to underestimate, the waiting itself, measured not in minutes but in days. An ambush predator's patience is its central skill, and the tarantula's is extraordinary. It can hold its position at or near the burrow mouth for hours that run into days, legs resting on the tripline's body utterly still, asking nothing of the world but that something edible eventually crosses a thread. There is no restlessness in it, no wandering off to seek better odds. The strategy is to wait in the right place and let probability do the hunting and the spider's frugal, slow-burning body. The one we met in the uncanny is what makes such patience affordable. To an observer, nothing would seem to be happening at all. A still spider at a dark hole for a day for two. But that stillness is the hunt. Every motionless hour is the strategy working exactly as designed, the animal spending almost nothing while the forest delivers prey to its door on the forest's own schedule. From stage 4 onward, this is the rhythm we'll return to, the long, slow patience underneath the rare sudden strike. The tarantula has made waiting into a form of action, but where it waits is a decision, and a shrewd one. A tarantula does not dig at random. The placement of a burrow is a piece of practical judgment, and survival rides on getting it right. The spider favors ground that holds the right moisture near enough to dampness to keep its body from drying out, but not so wet that the tunnel floods. It seeks cover, the shelter of a rock, the anchoring roots of a tree, the concealment of leaf litter that hides the entrance from the predators that hunt tarantulas. And it benefits from a site where prey is likely to pass, a position along the small highways of the forest floor where insects and other animals move. Get these factors right, and the burrow becomes a home that can last for years. Get them wrong, and the spider faces flooding, drought exposure, or hunger. So the choice of where to dig is a quiet act of assessment, reading moisture cover and traffic, and committing to a single spot that must serve as fortress, nursery, and hunting blind all at once. It is one more place where the dismissive picture of the spider falls apart. This animal is not simply reacting to the world, it is sizing it up and choosing. Not every burrow stays open to the night. Some of the tarantula's close relatives, the trapdoor spiders, members of the same ancient megalomorph lineage, sharing the same downward-stabbing fangs, take the engineering one step further and seal the entrance entirely. They build a door, spun from silk mixed with soil and bits of leaf and moss. The door is hinged on one side with a flexible band of silk, and its top is camouflaged so perfectly with the surrounding ground that a passing eye predator or prey slides right over it. The spider waits beneath, holding the door slightly ajar or shut, front legs reading the silk, and when prey crosses close enough, it bursts the door open, seizes the meal, and vanishes back below the door, falling closed behind it as if nothing happened. The underside has small holes the spider grips with legs or fangs so it can haul the door shut and hold it against an intruder trying to pry in. A few tarantula species build versions of these lids too, especially as juveniles. Think about the sophistication: a hinged, camouflaged gripping door, manufactured from silk and earth, built into the ground by an animal with a brain smaller than a grain of rice. This is not instinct as we condescend to it. This is engineering. Whether it builds a door or not, the burrowing spider faces a problem we rarely credit it for solving: finding its way home. The tarantula's eyes, remember, barely function, and yet a spider that leaves its burrow driven out to feed at the edge, or a male wandering in search of a mate, must somehow relocate the single small hole in the ground that means safety in a dark and tangled forest. Without useful sight, it manages by other means the chemical signature it has laid down in silk and scent, the feel of familiar ground beneath tasting feet, a learned sense of the immediate territory built up over time. Sight-faithful spiders can hold and return to a single burrow for years, defending and repairing the same address across a long life. Picture the navigation problem fairly. Erase your vision down to vague light and shadow, then find your front door across a cluttered landscape using touch, taste, and memory alone. The tarantula does exactly that routinely in the dark. The animal we picture as a static lump is when it must be a navigator carrying a working map of its world in senses we don't even have, and using it to find its way back to the one spot on Earth that is home. All of this runs on silk, and the range of what the spider does with that single material is the quiet marvel. The same substance, drawn from the same spinnerets, becomes many different tools depending on need. It lines the burrow walls, smoothing and stabilizing them. It forms the trip lines that wire the perimeter for vibration. It lays down chemical-scented drag lines that mark territory and, in season, advertise for mates. It builds the hinged door where the spider makes one. Later in the female, it will wrap and protect the eggs. One material spun on demand from the animal's own body, reshaped into structure, alarm system, signpost, door, and nursery as the moment requires. We tend to think of spider silk as one thing, the stuff of webs. In the tarantula, it is closer to a universal building medium, a manufactured fiber the animal deploys with real versatility across every part of its life. The spider is not just a hunter that happens to make silk. It is a creature whose silk is woven literally through everything it does, moving through the world, trailing a material it can turn to almost any purpose it needs. And now the strangest chapter in the whole life, the molt. To grow, remember, the tarantula must escape the rigid shell it has outgrown, and so every so often it performs one of the most extraordinary acts in the animal world. It builds a complete new body beneath the old one, then climbs out of itself. The spider sheds not just an outer skin but the entire exoskeleton, the covering of the legs, the lining of the book lungs, the surfaces of the stomach, and the fangs themselves, all of it cast off as a single hollow husk. To break free, it pumps hemolymph from its abdomen forward into its head and chest, raising the internal pressure until the old shell splits along built-in seams. And then it slowly, painstakingly works its body out through the gap, drawing each leg free like a hand pulled from a tight glove. What it leaves behind looks uncannily like a second empty spider lying beside it. Watch a time-lapse of it, and the only honest reaction is awe. An animal disassembling and re-emerging from its own skeleton, fangs and all, replacing nearly every hard surface of its body at once. And for a stretch of time around this act, the spider is more vulnerable than at any other moment in its life, because the new body comes out soft. When the tarantula first emerges from the old shell, its fresh exoskeleton has not yet hardened. The fangs are soft, the legs are weak, the whole animal is pliable and defenseless, unable to bite effectively, unable to flee with any speed. It must simply wait, sometimes for days, while the new shell cures and stiffens around it, and until it does, the hunter is helpless. So the spider prepares. It feels the molt coming and readies itself well in advance. It stops eating often for a long stretch. Large tarantulas may refuse food for weeks or months before a molt clearing its system and reducing the risk of a half-digested meal, complicating the shed. It retreats to the safest place it has, the depth of its silk-lined burrow, behind whatever defenses it can muster. The pre-molt spider, sluggish and off its food, is not sick, though it can look it. It is getting ready to become briefly completely vulnerable, and it is taking every precaution it can to survive the gap. The most dangerous hours of a tarantula's life are the ones it spends growing, and the animal knows enough to brace for them. The vulnerability has a posture, and it is the most defenseless image in the spider's whole existence. To molt, the tarantula flips onto its back. Legs pointing upward, soft belly exposed to the world, it lies inverted and still, sometimes for many hours, using gravity and the swelling pressure inside it to help work the new body free of the old. For an animal whose every other instinct is to keep its armored top toward danger and its soft underside hidden, lying deliberately on its back legs in the air, is a profound surrender of all defense. Keepers know the sight well, and they know the rule that comes with it. A tarantula on its back is not dying, it is molting, and it must not be disturbed, because interference at this moment can be fatal. There is a hard, clear tell that separates this from death. A dying spider curls its legs underneath itself, upright, drawn in. A molting spider lies on its back with its legs open to the sky. The same animal, two opposite postures, two opposite meanings. And the upturned one, the one that looks most like the end, is in fact the animal at the very center of growing more alive and more exposed than at any other time. The molt holds one more gift, almost magical in its implications. It is how a tarantula heals what should be unhealable. Lose a leg to a predator, to a struggle, to a molt gone wrong, and the spider does not simply live maimed for the rest of its life. At the next molt, a new leg emerges in the old one's place, small at first, not yet full-sized but functional, and growing closer to normal with each successive shed until over a few molts the limb is largely restored. The same process that lets the animal grow also lets it rebuild. Every molt is a chance not only to get larger but to repair, to replace damage that in an animal with a fixed adult body like ours would be permanent. Picture losing a finger, and then after a period of waiting, simply growing it back a little more each time you renewed your skin. For the tarantula, this is not miracle but mechanism woven into the same strange act of shedding its skeleton. The spider that climbs out of itself climbs out renewed, not just bigger but mended, carrying forward a body that can erase its own injuries one molt at a time. Now the silk and the senses turn toward something other than hunting, toward finding another of its kind. When a male tarantula reaches maturity and the urge to breed takes hold, he goes looking for a female, following the chemical scent trails she has left in silk and on the ground until he locates the threads leading to her burrow. And then at the entrance he does something remarkable. He drums. He taps and vibrates against the silk and the ground in a deliberate rhythm, sending a coded signal down into the burrow where the female waits. This is communication, precise and purposeful, a percussive language played through vibration, the same medium the spider uses to hunt now used to speak. Not the random tremor of stumbling prey, but a patterned, rhythmic signal that announces another tarantula of the right species with intent. Researchers studying these courtship displays describe species-specific patterns, as if each kind of tarantula drums in its own dialect. Stand close enough at the mouth of the burrow, and you would feel more than hear the faint, insistent tapping a suitor at the door, knocking in the only language the dark allows. And that knock is one of the most dangerous walks in nature, because the female he is courting is larger than he is, and she may be hungry. To the female tarantula resting in her burrow and reading vibration at the entrance, an approaching male is ambiguous. He could be a mate, or he could be a meal, and her instincts are tuned to seize what crosses her threshold. The male approaches a creature that outweighs him, fully capable of killing and eating him, and whose first interpretation of his arrival might simply be food. This is why the drumming matters so much. His rhythmic signal is in part a desperate clarification, an attempt to mark himself before he comes any closer as mate and not prey. Everything about his approach is cautious, deliberate, hedged against the real possibility that the encounter ends with him devoured rather than accepted. Picture the stakes plainly. To pass on his life, the male must walk willingly up to a larger predator of his own kind, announce himself, and hope she reads the message correctly. The courtship of the tarantula is not a gentle thing. It is a hunter approaching a hunter, staking his life on being understood. So how does a male survive a mate that may try to kill him with a set of tools that exist for this single deadly meeting? When a male tarantula takes his final molt into adulthood, his body changes for the encounter ahead. His legs grow longer and leggier for the long search. His pedipalps swell into bulb-tipped organs that look almost like tiny boxing gloves. Loaded with sperm, and on his first pair of legs in many species, he grows a pair of hooks. These are the tibial hooks, small, curved spurs, and their purpose is brutally specific. When the male finally meets the female face to face, both of them rearing up with fangs exposed, he uses these hooks to catch and clasp her fangs, physically holding her bite away from his body while he works. One researcher described the whole frantic act as trying to make a slam dunk into a fanny pack while holding up a wrestler and not getting eaten all at once. The hooks are the only thing standing between courtship and consumption, an entire anatomy grown at the last molt of his life for the sole purpose of restraining a partner who might otherwise make a meal of him. He signals mate, not meal, with his drumming, and then when signaling is no longer enough, he holds her fangs back with his legs. The meeting itself plays out as a tense, deliberate ritual at the mouth of the burrow. The male arrives and taps that patterned species-specific drumming on the silk and the soil, and then he waits, reading the female's response in the vibrations that come back. He does not rush in. He cannot afford to. the encounter can end with him seized and eaten before he ever mates. So the whole approach is a careful negotiation conducted through touch and rhythm signal: wait, red, advance. Only if she accepts does he come close enough to rear up against her, hook her fangs and transfer his sperm with those bulb-tipped pedipalps, and then the instant the act is done, he runs. A timely exit is everything. Picture the scene at the dark burrow. Mouth, two armored animals reared up and locked together, fangs against hooks, the smaller one working against time, every instinct in the larger one telling her that the thing in her grasp could just as easily be food. The tap and wait ritual is courtship conducted at knife point, patient, precise, and utterly without guarantee. Underlying all of this is a quieter ability we tend not to credit. A spider with it can tell who is who. The tarantula reads chemical signatures from the world around it, the scent marks left in silk and on the ground, and from them it distinguishes a potential mate from a rival, a member of its own species from a stranger. The male follows exactly these chemical trails to find a female of the right kind. The female's scent advertises her presence and her readiness, and the recognition runs deep enough that the reproductive machinery itself enforces it across tarantula species. The male's and female's sexual structures fit together like a key in a lock, matched so specifically that a mismatched pair often simply cannot mate. So identity matters at every level: chemical, behavioral, even mechanical. This is not an animal blundering blindly into whatever it encounters. It is an animal that reads the signatures of its own kind, that knows the difference between a mate and a meal and a rival, that recognizes through chemistry and structure both who belongs and who does not. The tarantula moves through a social world we can barely perceive, one written in scent and silk, and it reads that world with a precision its tiny nervous system has no business achieving. That reading is learned as much as it is given. A tarantula holding a single burrow across years comes to know its small patch of the world intimately. The layout of the ground around its door, the reliable paths that prey tends to travel, the safe lines of retreat, the texture and chemistry of its own territory mapped through tasting feet and trailing silk. This is not a creature dropped fresh into each moment with no memory of the last. It is an animal accumulating familiarity with one place over a long life, building up a working knowledge of its surroundings that sharpens its hunting and steadies its navigation. Scientists studying tarantulas and their relatives describe animals capable of learning, of adjusting behavior to local conditions. The thickness of a door tuned to the local soil, the placement of trip lines shaped by where prey actually moves. The spider learns its home, and in an animal we are tempted to dismiss as pure reflex, that learning is its own small marvel, a long-lived hunter that does not merely react to its territory but comes over years. To know it to carry a map of one corner of the forest in a brain the size of a pinhead, refined by everything that has happened there before. Even the famous hair flick turns out to be more controlled than it looks. When a New World tarantula releases its cloud of urticating hairs, it is not a random panicked shedding, it is an aimed defense. The spider orients its abdomen toward the threat and rakes with its hind legs to direct the barbed hairs at the specific target that is troubling it. Whether that's a predator's face or an intruder at the burrow. Over a lifetime of doing this, some tarantulas wear a visible bald patch on the abdomen where the hairs have been used and not yet regrown. The mark of a weapon deployed many times, aimed and fired and aimed again. There is real economy in it. The hairs are a finite resource between molts, and the spider does not waste them. It reads the threat points and releases toward where the danger actually is. What looks from the outside like a spider frantically throwing pieces of itself is on closer inspection a directed act. A defense, with a target delivered with surprising control by an animal aiming a cloud of microscopic harpoons at the one thing in its world it most wants to drive away. And when the hairs aren't enough, the spider escalates through a display that is almost entirely theatre. The reared-up posture we met in the dread front legs, lifted fangs, bared body, tilted back into a wall of menace, is first and foremost a performance, a threat meant to end the confrontation without a bite ever being delivered. The tarantula is making itself look as large and as dangerous as it possibly can, gambling that the sight alone will be enough to send a predator looking for easier prey. Most of the time the gamble pays. The display works precisely because it does not have to become a fight. The bared fangs are a promise the spider would rather not keep, since biting costs, venom risks, injury, and exposes the animal to a larger attacker it cannot actually beat in a real struggle. So the threat is mostly bluff layered over genuine capability, a last warning shouted in body language. The spider rears, holds the pose, and waits to see if the danger withdraws. The whole towering, fang-flashing spectacle is built on a hope as old as predators and prey, that looking dangerous will mean never having to prove it. Strip all of it back, and you're left with the central wonder of this animal, a hunter that is nearly blind and strikes even so with precision. Its 8 eyes barely register more than light and shadow, and it hunts in the dark regardless. And yet, again and again, it places that downward strike exactly where it needs to land, driving its fangs into a moving frog, a darting insect, a fleeing mouse with an accuracy that vision could not improve upon. It does this entirely through vibration and touch, the tremor traveling up a trip line. The air current, a moving body, pushes ahead of it, all assembled by sensory hairs into a target the spider can hit without ever seeing it. Sit with how strange that is. We tie accuracy to eyesight so tightly we can barely imagine one without the other. The tarantula severs the two completely. It is a precise predator in the dark, aiming by feel, landing a committed downward strike on a target. It has never once laid eyes on a hunter. That proves, in the most literal way, that you do not need to see your prey to catch it. And so the awe resolves into a single, almost philosophical point: for this animal, doing nothing is the strategy. Everything we have walked through, the engineered burrow, the wired trip lines, the frugal, slow-burning body, the patient wait, the restrained venom, the bluffing display, all of it serves one quiet logic. Stillness keeps the tarantula alive. It saves energy that a fast, restless animal would burn. It avoids the fights it cannot win. It lets prey come to a fixed position rather than spending the spider's strength on the chase. In a world that rewards speed and aggression in so many other predators, the tarantula has won by doing the opposite, by waiting, by conserving, by acting only in the rare instant when action pays. The economy of stillness is not laziness. It is a deeply successful answer to the problem of staying alive, refined across hundreds of millions of years. The most striking thing about this hunter in the end is how little it does and how well that works. It has built an entire existence on the radical efficiency of patience, a life in which the smartest move almost always is simply to wait. And it is that patient body and that long life that we turn to next. The female's reward for surviving the mating is a burden she will carry for weeks. Some time after the male escapes, she produces an egg sac, a tough silken case. She spins herself, and into it she lays her eggs. The numbers strain belief. Across tarantula species, a single sac can hold anywhere from 50 eggs to 2,000, and in the largest species the count climbs higher still, toward 3,000 in one clutch. She does not lay and leave. She binds the eggs in silk, draws the sac close, and begins a vigil that will consume the next stretch of her life. Picture a single spider guarding in one silk parcel a number of offspring that can rival the human population of a small town, 1,000 lives, 2,000, sealed in a case she spun from her own body and now will not let out of her grip. The leap from the lone hunter, patient and solitary in its dark burrow, to this, a mother cradling a multitude, is one of the strangest turns in the animal's whole story, and it begins with a silk parcel held close in the dark, swollen with more lives than the spider could ever count. And she guards that sac with a devotion that rewrites everything fearsome about her. For 6 to 8 weeks, the female stays close to her egg sac, rarely leaving it, turning it regularly so the eggs inside don't settle and deform under their own weight, a behavior called brooding. In some species, she carries the sac to the mouth of the burrow to warm it in the sun, then draws it back into safety, managing its temperature and humidity by hand. Through all of it, she grows more aggressive, more willing to defend, because now there is something behind her worth the risk of a fight. The same animal we have watched bluff and flee and avoid confrontation will for this stand her ground. Sit with the tenderness hidden inside the monster. This dinnerplate spider, this venom-fanged hunter of the dark, spends the better part of 2 months gently rotating a bundle of eggs so that her unborn young will not be crushed by their own stillness, warming them, shielding them, refusing to leave them a mother, keeping watch over 1,000 lives in the blackness of a day. Burrow asking nothing and guarding everything. Then all at once the burrow fills with movement. When the eggs hatch, spiderlings emerge, not a handful but hundreds, tiny replicas of the adults spilling from the sac into the chamber their mother has kept for them. For a time they stay close, sheltering in or around her burrow through their first days and first molts, living at first off the last of their yolk before they are ready to face the world. In some species the mother lingers with them, guarding the cluster for a stretch of days before they scatter. In others they strike out almost immediately. But there is always this moment, the burrow, so long the domain of a single solitary hunter, suddenly alive with hundreds of miniature spiders. A brief and crowded nursery in the dark. Imagine the floor of that tunnel seething with motion, every tiny body a perfect small copy of the giant that made it, all of them stirring at once into the only world they will ever know. The lone predator's lair becomes for a few days the most populous place in the forest floor, and then just as quickly it begins to empty, as the hundreds prepare to go their separate ways into a world that has been waiting to thin their number. To see them emerge is to watch a handful of dust come alive. The spiderlings are minute, so small that a whole brood of them together looks less like animals than like a scattering of grains stirred by wind, a fistful of moving dust pouring out across the burrow floor. Each one carries in miniature the complete machinery of the giant. It may become the 8 legs, the folding fangs, the book lungs, the tasting feet, the capacity to spin silk, and someday to grow into something the width of a dinner plate. Everything is already there, shrunk to the size of a speck. Hold the wonder of that scale in your mind, that the enormous, heavy, fearsome Goliath bird-eater began exactly here as one of hundreds of nearly weightless motes spilling from a silken sack, indistinguishable from its siblings smaller than a written word on this page. The largest spider on earth starts its life as a grain of living dust among hundreds of identical grains, and the vast distance between that speck and the giant. The years, the molts, the patient growing is a journey that almost none of them, spilling out together into the dark, will ever finish. Because the truth waiting for those hundreds is merciless, almost none will survive. Of the hundreds of spiderlings that spill from a single sac, only a tiny fraction will reach adulthood. Most are eaten by predators or fail to find enough food, or perish in the countless small disasters that befall something so fragile, so numerous. This is the hard arithmetic behind the enormous clutch. The female does not lay 1,000 eggs because 1,000 will live. She lays 1,000 because the world will take nearly all of them, and a handful surviving is enough to carry her line forward. The crowded nursery is from the start a kind of lottery, with almost no winners, hundreds of identical lives, launched into a world that has every intention of ending most of them within weeks. There is something both brutal and quietly staggering in the strategy, a mother pouring everything into a multitude precisely because the multitude will be devoured, betting on overwhelming numbers against overwhelming loss, so that out of 1,000 grains of living dust, the 2 or 3 that slip through every net will grow in time and in darkness, into the giants that begin the whole patient gamble again. For the few that survive, growing up means shedding the body again and again. A tarantula does not grow steadily the way you did, lengthening a little each month. It grows in sudden steps, molt by molt, holding the same size for a stretch, then casting off its entire exoskeleton and emerging slightly larger, then holding again until the next shed. Its whole life is measured not in months but in molts, each one a discrete leap to a bigger body. Young tarantulas molt, often several times a year, as they climb toward adult size. The intervals stretch longer as they mature. Picture growth not as a smooth rising line, but as a staircase, long, flat treads of unchanging size, broken by sudden vertical jumps each time the animal escapes its old shell and unfolds a larger one. The distance from a grain of dust to a dinner plate giant is climbed one molt at a time, each shed, a small, dangerous miracle of building a new body and stepping out of the old. To grow, this animal must repeatedly disassemble and rebuild itself, and so a tarantula's age is written, more honestly than in any calendar, in the count of the skeletons it has left behind. and if a female survives that long climb, she earns something almost no spider gets: decades. A female Goliath bird-eater can live 15, 20, even 25 years, and across tarantula species the very longest-lived females may reach 30 years or more, figures that place them among the longest-lived of all spiders, and indeed among the more long-lived land invertebrates anywhere. A close relative, a wild trapdoor spider, was documented living to the astonishing age of 43. Set that against the brief, frantic lives of most spiders, which flicker out in a single year, and the female tarantula stands as a creature operating on a wholly different timescale, slow to mature, slow to age, persisting in the same burrow while seasons turn over her again and again for the better part of a human child and beyond. There is a strange dignity in that longevity. A patient near-blind hunter, sitting in one dark hole in the rainforest floor, can outlive the family dog several times over, can be alive waiting at the mouth of the same burrow, longer than some of the people who fear her have been alive themselves. The giant of the dark is not only large, she is old, and she keeps on living quietly for a very long time. The male is granted no such span, and the contrast is almost cruel. Where the female measures her life in decades, the male measures his in months. He takes years to reach maturity like her, but once he takes that final molt into adulthood, his life burns down fast. In many species, a mature male lives only a year or so beyond it. In some, like the desert tarantula, just 2 or 3 months. His maturity is essentially a death sentence, with a single purpose attached: find a female mate and die. Everything about his final form serves that one errand: the long roaming legs, the sperm-loaded pedipalps, the fang-catching hooks, the abandonment of the safe burrow for the dangerous open search. Picture the two of them side by side, hatched from the same sac, shaped by the same long years of growing, and then at adulthood splitting onto utterly different roads. She settles into a vigil that may last 30 years. He sets out into a few desperate weeks, walking toward a larger mate who may kill him, racing a clock that is already nearly spent. The same animal, the same beginning, and 2 lifespans so far apart they hardly seem to belong to one species at all. That gulf shows up in their bodies long before death does, because the male and female are built to different scales. In tarantulas, the female is the larger sex, heavier, bulkier, more robust, while the mature male is smaller, lighter, leggier, slimmed down for travel rather than bulked up for power. The difference can be stark. In some species, the female dwarfs the male outright, a heavy-bodied giant beside a slender, long-limbed wanderer. And this size gap is exactly what makes the male's courtship so perilous, because the partner he must approach and clasp and signal to is not his equal in a struggle. She is bigger than he is, stronger than he is, and fully capable of overpowering him should the meeting turn. Everything we saw in the courtship, the cautious drumming, the fang-catching hooks, the instant retreat, traces back to this basic asymmetry of the bodies. He is the small one approaching the large one, staking his brief life on her restraint. The sexes of this species are not 2 versions of the same size. They are a giant and a much smaller suitor, and the whole strange, dangerous dance of their meeting is shaped from beginning to end by the simple fact that she could so easily destroy him. The slow life carries a slow appetite, and the tarantula can stretch a single meal further than seems possible. This is an animal that can go a very long time without eating: weeks, easily, often months, and in some recorded cases far longer. A large female, well-fed and at rest in her burrow, can simply wait out a lean stretch, her frugal metabolism burning so little that hunger arrives only slowly. Some tarantulas have been kept alive on water alone for as long as 2 years. 2 years. Set that against your own body, which begins to fail within weeks of true starvation, and the gulf is staggering. The same slow-burning physiology that lets the spider sit motionless for days in ambush also lets it endure famine that would kill almost anything its size. It does not need a steady supply of food. It needs occasionally enough, and between those occasions it can wait and wait and wait, drawing down its reserves at a pace so gradual that a missed season or several is no emergency at all. The patience we admired in the hunt turns out to run all the way to the bone, a creature that can outlast not only its prey, but the very absence of prey, holding steady through a hunger that has no business being survivable. That endurance is what lets the tarantula ride out a world that regularly turns hostile. Sealed in its burrow, the spider can survive the disasters that scour the surface, the drought that bakes the ground, the flood that drowns it, the long stretches when prey vanishes and the forest floor offers nothing. The burrow buffers it, the silk-lined tunnel holds humidity against the dry, offers refuge against the wet, and the animal's deep reserves of patience and fat carry it through the famine between. Where a creature that must eat often, or stay cool often, or drink often, would perish when conditions turn, the tarantula simply withdraws and waits for the world to right itself. It has made a life out of weathering the unweatherable, out of being the thing still alive in the burrow when the hard season finally breaks. There is a quiet resilience in that, the toughness not of strength but of endurance, of a body and a home built together to outlast bad times rather than fight them. The giant of the dark does not conquer drought and flood and famine. It outwaits them, sealed in the earth, spending almost nothing holding on in the dark, until the rains return or the prey comes back or the ground cools, and then unhurried emerging again into a world that tried and failed to end it. Step back and the shape of the whole life comes into view, and it is a life lived almost entirely in waiting. Strung together, the tarantula's existence is mostly stillness. The long ambush at the burrow mouth, the motionless weeks before a molt, the patient guarding of an egg, sack the endurance through famine and drought. The decades a female spends in a single hole in the ground. The bursts of action, the strike, the molt, the dangerous courtship are real, but they are rare, brief punctuation in an existence whose dominant tense is the pause. This is an animal that has made waiting its native condition, that experiences time at a tempo so slow we can barely share it. A creature for whom doing almost nothing for almost all of its long life is not failure or idleness, but simply what living is. There is something close to alien in that rhythm, and something close to peaceful. While the forest around it races through generations of fast, frantic, short-lived creatures, the tarantula sits and waits and persists, measuring out one of the longest lives on the forest floor in units of patience. Present for decades, and active for only moments, a still point in the dark around which the quick lives of the world spin and burn and are gone. And this patient life is not rare or cornered, it is spread across nearly the whole warm world. Tarantulas are not a single exotic curiosity of one rainforest. They are a vast, far-flung family found across the tropical and subtropical regions of the Americas, Africa, Asia, and Australia, inhabiting deserts and rainforests and grasslands alike. The Goliath stalks the Amazon, the king baboon digs the dry soil of East Africa, the cobalt blue burrows in the forests of Southeast Asia, desert species line tunnels in the arid American Southwest. Wherever the climate stays warm enough, some tarantula has found a way to live there, adapting the same ancient body plan to swamp and savanna and dune. Picture the reach of it, a single family of giant spiders woven through the warm belt of the entire planet. Thousands of species occupying nearly every kind of dryland habitat. The tropics and subtropics offer each one a local variation on the same deep theme of patience and ambush and silk. The giant of the dark is not a rarity glimpsed in one corner of one jungle. It is a near global presence, sitting quietly in burrows and crevices and trees across most of the warm surface of the earth, far more widespread and far more various than the fearful imagination ever pictures. That variety includes a fundamental split in where they live. Some tarantulas have left the ground entirely. While the Goliath and the king baboon are terrestrial burrowers anchored to tunnels in the earth, other species are arboreal tree dwellers that spend their lives up in the trunks and branches, sheltering in hollows under bark, in silk-lined retreats woven into the canopy rather than dug into the soil. These arboreal tarantulas tend to be built differently for the life, leggier, lighter, quicker, suited to climbing and clinging and striking in 3 dimensions rather than ambushing across a flat forest floor. It is the same fundamental animal, the same fangs and silk and patience, transposed from the dark of a burrow to the height of a tree. Consider what that range represents. The tarantula body plan is versatile enough to have conquered both the underground and the canopy, to produce a heavy, deep-digging giant in one lineage and a slender, agile climber in another, each thriving in a world the other could barely survive in. The family did not settle on one way of living. It branched, sending some of its members down into the earth and others up into the trees, and built from the same ancient blueprint hunters for both the floor and the sky of the forest. And then there is the color, which is the last thing you expect. We have been picturing the tarantula in browns and blacks, the dull bristled hair of the Goliath, and many are exactly that. But not all. Some tarantulas are spectacularly, almost unbelievably vivid. The cobalt blue, its legs shining a deep metallic blue. The gouty sapphire ornamental, wrapped in an intricate geometric pattern of brilliant blue. The green bottle blue, with electric blue legs around a green-gold body. Species in greens and purples and burning oranges. These are not the muted tones of a creature hiding in shadow. They are jewel colors, the kind of brilliance you associate with tropical birds or butterflies worn by giant spiders. Hold the surprise of it against everything the word tarantula conjures. The animal we file under nightmare hairy dark lurking includes among its thousands of species some of the most gorgeously colored creatures on the forest floor. Spiders that look less like monsters than like living gemstones. Their legs flashing electric blue as they move. The giant of the dark is, in many of its forms, not drab at all. It is radiant, and that radiance on an animal built for shadow raises a question that turns out to be genuinely unsolved, because the blue itself is a small scientific mystery on two separate counts. First, how the color is made. The vivid blue of these tarantulas is not pigment at all. There is no blue dye in the hairs. Instead, the color is structural, produced by microscopic nanostructures built into the hairs themselves, shaped to scatter and reflect blue light. The same trick of physics that colors a blue morpho butterfly or a peacock's feather. The blue is in a sense an illusion of architecture, light bent by structure rather than soaked in pigment. And second, the deeper puzzle, why? Researchers have found that this blue evolved independently, many separate times across the tarantula family, by one count at least 8 times, and strikingly, the spiders don't all build the blue the same way, which suggests the color isn't just an accidental byproduct of some other useful trait. Something is favoring blue again and again in animals that are nearly blind and largely nocturnal. Scientists still debate what use is a brilliant blue to a creature that can barely see and hunts in the dark that its own kind can scarcely perceive. Nobody yet knows for certain. The giant wears a color it seemingly cannot use, made by a structure of startling precision, evolved over and over for reasons that remain for now genuinely unexplained. The family stretches just as dramatically in size, from giants down to creatures you could lose on a fingertip. At one end stands the Goliath bird-eater, the dinner plate heavyweight we began with, the largest spider on Earth by mass. At the other end are tiny tarantulas species like the small arboreal jewels of the South American rainforest, some with bodies barely longer than a fingernail, a fraction of the Goliath's bulk in every dimension. Set the largest and the smallest side by side, and they hardly seem to belong to the same family. A spider, the width of a place setting, and a spider that would sit comfortably on a thumbnail, both built on the identical ancient plan of 2 body sections, 8 legs, folding fangs, and spun silk. The range is a measure of how successful that plan has been, flexible enough to scale from a near weightless speck in the treetops to the heaviest spider alive, filling every size of predatory niche in between. The same blueprint that produced the giant of the dark also produced its miniature cousins, the whole sweep of them sharing a body and a strategy across an enormous range of scale. To know tarantulas only by the Goliath is to know one end of an extraordinary spectrum, a family that has built from one design both the colossus and the jewel, and we are still even now counting them. The number of named tarantula species already runs to well over 900 by recent reckonings, more than 1,000 spread across well over 100 genera, and that tally keeps climbing as new species are described. The electric blue tarantula of Thailand's mangroves was formerly named, only recently found on a tree and new to science. Each year, researchers add more, pulling previously unknown tarantulas into the catalogue from forests and deserts and mountainsides around the warm world. Sit with what that means. A family of large, conspicuous, charismatic animals, not microbes, not deep-sea obscurities, but giant spiders, we have feared and kept and filmed for generations, and we still do not have a complete list of its members. There are tarantulas alive right now in forests and burrows across the planet that no scientist has ever described, that have no name, that we do not yet know exist. The giant of the dark is not a closed book. It is an open and growing one, a family whose full membership is still being discovered, reminding us that even among the most familiar monsters of our imagination, the natural world is still keeping count of creatures we have never met, and that the catalogue of life, even at this scale, is nowhere near finished. And every one of these creatures, the giant and the jewel, the burrower and the climber, descends from a lineage almost unimaginably old. Tarantulas are ancient. Scientists estimate the group first emerged around 120 million years ago in the Cretaceous, when the spiders we would recognize as tarantulas were already walking a world ruled by dinosaurs. Back then, the southern continents were joined in the great landmass of Gondwana, South America, fused to Africa, India, and Australia, and the tarantulas riding the slow breakup of that supercontinent as it tore apart over tens of millions of years were carried to the far-flung homes they occupy today. Sit with the depth of that time. The animal in the burrow tonight belongs to a family that watched the continents themselves drift into their modern shape, that was old when Tyrannosaurus walked, that has persisted through the asteroid and the long ages after scarcely changing its ancient design. The giant of the dark is not just a creature with a long individual life. It is the living end of one of the deepest lineages on land, a survivor not of years or decades but of geological eras, carrying a body plan forged before the flowers fully bloomed, before the dinosaurs fell into the warm forests of a world its earliest ancestors would still in the dark recognize as home, which leaves us at the close of all this wonder with a single, quiet truth about the design itself. It worked so well, it barely had to change. The tarantula's body, the exoskeleton, and the book lungs, the 8 legs, and the blue blood, the folding fangs, and the spun silk, and the patient still hunting life, is not a recent invention being refined towards something better. It is an old and finished answer settled upon deep in the age of dinosaurs and carried almost untouched across 100 million years and more, because it solved the problem of being a large patient ambush predator so completely that evolution found little worth altering. The continents moved, the climate turned over, the whole worlds of other animals rose and vanished, and the tarantula simply kept being the tarantula, the same essential creature in the same essential shape, generation after generation, era after era, down to the spider waiting in its burrow at this very moment. There is a strange and humbling permanence in that. We are looking, when we look at a tarantula, not at a work in progress, but at a kind of completion, a way of being alive so durable, so thoroughly successful, that it has outlasted nearly everything around it by staying almost exactly the same. The wonder of this animal is not that it changed. It is that for 100 million years it so rarely needed to. But an animal this old and this widespread does not simply exist in the world. It holds the world up quietly from below. Begin with the most practical truth about the tarantula, the one that should reframe every shudder it provokes. It is one of nature's great controllers of pests. A tarantula eats across its long life an enormous quantity of insects and other small invertebrates, the crickets, beetles, roaches, and countless crawling things that unchecked would swell into far greater numbers. Spread that appetite across the thousands of tarantula species and the billions of individuals living throughout the warm world, and the family becomes a vast, silent force, keeping insect populations in balance. Burrow by burrow, night by night, across whole continents, the animal we fear as a predator is, from the ecosystem's point of view, a regulator, a steadying hand on the teeming insect world, doing work we would sorely miss if it stopped. Think of the giant in its burrow not as a horror lurking in the dark, but as a part of the machinery that keeps the forest functioning, eating its share of the small and the many so their numbers never overwhelm the rest. The tarantula is not a flaw in the world's design. It is one of the quiet things holding that design together. And here is the detail that should melt the last of the fear. Some tarantulas keep a tiny frog as a companion and they do not harm it. In the rainforests of South America and parts of Asia, certain large tarantulas share their burrows with small microhylid frogs, the spider and the amphibian living side by side in the same dark hole, sometimes alongside the spider's own eggs and young. The giant predator, fully capable of eating the frog in an instant, simply doesn't. It appears to recognize the frog by chemical cues and stays its fangs. And the arrangement helps them both. The frog gains shelter from the heat and a safe place near a powerful protector, and in return it eats the small ants and insects that would otherwise raid the spider's burrow and devour her eggs. The tiny frog is a live-in pest controller for the giant spider, and the giant spider is a bodyguard for the tiny frog. Picture it, the monster of our nightmares curled in its burrow beside a frog, no bigger than a thumbnail, the two of them at peace in the dark, each quietly keeping the other safe. The animal we cast as a remorseless killer turns out to be capable of something that looks, from the outside, remarkably like friendship. For all its size and venom, the tarantula is far from the top of its world. Plenty of things hunt the hunter. Across its range, the giant of the dark is itself prey. Snakes take them, birds snatch them, and mammals like the long-nosed coati dig them out and eat them. Lizards, larger spiders, and a host of other predators all make meals of tarantulas when they can. And the spiderlings, those hundreds of grains of living dust, are eaten in vast numbers by almost anything small enough to want them. The fearsome giant spends its life not only as a predator, but as a target ringed by animals that would happily make it dinner, which is precisely why so much of its existence is built around hiding, waiting, and avoiding the fight. All those defenses we catalogued, the hiss, the barbed hairs, the bluffing rear up, the deep burrow, exist because this animal is genuinely constantly hunted. It is a reminder of where the tarantula truly sits, not as the apex terror of its world, but as one creature among many in the web of eating and being eaten, formidable to a cricket and a frog, but vulnerable itself to the coati's claws and the snake's jaws and the bird's quick beak. The monster, it turns out, spends its whole long life watching its own back. And among all the things that hunt it, one is the stuff of true nightmare, not for us but for the spider. It is the tarantula hawk, a large parasitic wasp, and what it does is grim beyond the spider's own hunting. When a female wasp finds a tarantula, she attacks it, and her sting delivers a paralyzing venom that does not kill the spider but freezes it, leaving it alive, aware, and utterly unable to move. Then she drags the paralyzed giant to a burrow, lays a single egg on its body, and seals it in. When the egg hatches, the wasp larva feeds on the living, helpless spider from the outside in, kept alive as long as possible so the meat stays fresh, consumed slowly over days until nothing usable remains. Hold the horror of that against everything we have feared about the tarantula. The giant that paralyzes frogs and liquefies mice meets in the tarantula hawk, a predator that does to it something worse than anything it does to its own prey, turning the hunter into a living larder, paralyzed and devoured alive in the dark. If the tarantula is a monster, then nature has built a monster's monster to hunt it. And the spider, for all its fangs, has no real defense against the wasp at all. Now the threats turn from the natural to the human, and they begin with something that looks like admiration. Tarantulas have become hugely popular in the global pet trade, wanted, kept, bought, and sold around the world precisely because they are large, striking, long-lived, and in many species breathtakingly beautiful. The vivid blues and jeweled patterns that puzzle scientists are exactly what drive demand among collectors, and the rarer and more gorgeous a species, the more intensely it is sought. There is real irony and real danger folded into that desire. The same beauty and fascination that might make us want to protect these animals also make them commodities and the most coveted species. The brilliantly colored rarities with tiny natural ranges are often the ones least able to withstand the pressure of being collected. Demand becomes a force of its own, reaching out from living rooms and online marketplaces across the world into specific small patches of forest where a prized species clings to existence. The tarantula's allure, the thing that should be its salvation, becomes instead a market, and the market, hungry for the rarest and most beautiful, presses hardest on exactly the animals that can least afford it. We have turned wonder into want, and want for some of these spiders into a threat, because that demand reaches straight into the wild. Many tarantulas sold to collectors are not bred in captivity, but taken directly from their habitats, dug out of their burrows, and pulled from their forests to be shipped across the world. For species with naturally small ranges and slow life cycles, this wild collection can be devastating, stripping animals from the very places they are rarest faster than they can possibly be replaced. Some of the most beautiful and sought-after species are also among the most narrowly distributed found in a single forest or region, and concentrated collecting from those few places can hollow out a wild population with frightening places and debotters. Speed. Conservationists have flagged the trade as a serious and poorly regulated risk, with monitoring and protections lagging far behind the booming online market. Picture what that means on the ground. A prized, jewel-colored tarantula, found nowhere else on Earth, but one shrinking patch of forest being lifted burrow by burrow and sent away to enclosures around the globe, until the forest that made it falls quiet. The animal that survived 100 million years, that outlasted the dinosaurs and rode the continents apart, can be emptied out of its last refuge in a few short years, not by any natural predator, but by the reach of human desire for a beautiful thing. And the deepest cruelty of that pressure lies in the spider's own slow biology. The very longevity we marveled at becomes its vulnerability. A tarantula species that takes years to reach maturity, that breeds slowly, that lives its long life at the patient tempo we admired, simply cannot replace its numbers quickly. Remove the adults from a wild population, and the gap they leave is not filled in a season or two. It takes many years for slow-growing young to mature and begin breeding. And during all that time, the population stays thin and exposed. The same unhurried life that lets a female reign in her burrow for 30 years means that a damaged population recovers at an agonizing crawl, if it recovers at all. The traits that make the tarantula such a marvel of endurance on the scale of a single life become, on the scale of a whole species under pressure, a fatal slowness. A fast-breeding animal can bounce back from heavy losses. The tarantula cannot. It was built to outlast drought and famine and the slow turning of eras, but not to outpace a sudden, sustained harvest by the one predator that collects faster than the spider can possibly replenish. Its great gift, longevity, offers no protection here. Against the speed of human demand, the patient animal has no patience left to spare, and every one of these creatures, the giant and the jewel, the burrower and the climber, descends from a lineage almost unimaginably old. Tarantulas are ancient. Scientists estimate the group first emerged around 120 million years ago in the Cretaceous, when the spiders we would recognize as tarantulas were already walking a world ruled by dinosaurs. Back then, the southern continents were joined in the great landmass of Gondwana. South America fused to Africa, India, and Australia, and the tarantulas riding the slow breakup of that supercontinent as it tore apart over tens of millions of prem. Years were carried to the far-flung homes they occupy. Today, sit with the depth of that time. The animal in the burrow tonight belongs to a family that watched the continents themselves drift into their modern shape, that was old when Tyrannosaurus walked, that has persisted through the asteroid and the long ages after scarcely changing its ancient design. The giant of the dark is not just a creature with a long individual life. It is the living end of one of the deepest lineages on land. A survivor not of years or decades, but of geological eras, carrying a body plan forged before the flowers fully bloomed, before the dinosaurs fell into the warm forests of a world its earliest ancestors would still in the dark recognize as home, which leaves us at the close of all this wonder with a single quiet truth about the design itself. It works so well it barely had to change. The tarantula's body, the exoskeleton and the book, lungs, the 8 legs and the blue blood, the folding fangs and the spun silk and the patient still hunting life, is not a recent invention being refined towards something better. It is an old and finished answer settled upon deep in the age of dinosaurs and carried almost untouched across 100 million years and more, because it solved the problem of being a large patient ambush predator so completely that evolution found little worth altering. The continents moved, the climate turned over, the whole worlds of other animals rose and vanished, and the tarantula simply kept being the tarantula, the same essential creature in the same essential shape, generation after generation, era after era, down to the spider waiting in its burrow at this very moment. There is a strange and humbling permanence in that. We are looking, when we look at a tarantula, not at a work in progress, but at a kind of completion, a way of being alive, so durable, so thoroughly successful that it has outlasted nearly everything around it by staying almost exactly the same. The wonder of this animal is not that it changed. It is that for 100 million years it so rarely needed to. But an animal this old and this widespread does not simply exist in the world, it holds the world up quietly from below. Begin with the most practical truth about the tarantula, the one that should reframe every shudder it provokes. It is one of nature's great controllers of pests. A tarantula eats across its long life an enormous quantity of insects and other small invertebrates, the crickets, beetles, roaches, and countless crawling things that unchecked would swell into far greater numbers. Spread that appetite across the thousands of tarantula species and the billions of individuals living throughout the warm world, and the family becomes a vast, silent force keeping insect populations in balance. Burrow by burrow, night by night, across whole continents. The animal we fear as a predator is, from the ecosystem's point of view, a regulator, a steadying hand on the teeming insect world, doing work we would sorely miss if it stopped. Think of the giant in its burrow not as a horror lurking in the dark, but as a part of the machinery that keeps the forest functioning, eating its share of the small and the many so their numbers never overwhelm the rest. The tarantula is not a flaw in the world's design. It is one of the quiet things holding that design together. And here is the detail that should melt the last of the fear. Some tarantulas keep a tiny frog as a companion and they do not harm it. In the rainforests of South America and parts of Asia, certain large tarantulas share their burrows with small microhylid frogs, the spider and the amphibian, living side by side in the same dark hole, sometimes alongside the spider's own eggs and young. The giant predator, fully capable of eating the frog in an instant, simply doesn't. It appears to recognize the frog by chemical cues and stays its fangs, and the arrangement helps them both. The frog gains shelter from the heat and a safe place near a powerful protector, and in return it eats the small ants and insects that would otherwise raid the spider's burrow and devour her eggs. The tiny frog is a live-in pest controller for the giant spider, and the giant spider is a bodyguard for the tiny frog. Picture it, the monster of our nightmares curled in its burrow beside a frog no bigger than a thumbnail. The two of them at peace in the dark, each quietly keeping the other safe. The animal we cast as a remorseless killer turns out to be capable of something that looks, from the outside, remarkably like friendship. For all its size and venom, the tarantula is far from the top of its world. Plenty of things hunt the hunter. Across its range, the giant of the dark is itself prey. Snakes take them, birds snatch them, and mammals like the long-nosed coati dig them out and eat them. Lizards, larger spiders, and a host of other predators all make meals of tarantulas when they can. And the spiderlings, those hundreds of grains of living dust, are eaten in vast numbers by almost anything small enough to want them. The fearsome giant spends its life not only as a predator, but as a target ringed by animals that would happily make it dinner, which is precisely why so much of its existence is built around hiding, waiting, and avoiding the fight. All those defenses we catalogued, the hiss, the barbed hairs, the bluffing rear up, the deep burrow, exist because this animal is genuinely, constantly hunted. It is a reminder of where the tarantula truly sits, not as the apex terror of its world, but as one creature among many, in the web of eating and being eaten, formidable to a cricket and a frog, but vulnerable itself to the coati's claws and the snake's jaws and the bird's quick beak. The monster, it turns out, spends its whole long life watching its own back. And among all the things that hunt it, one is the stuff of true nightmare, not for us but for the spider. It is the tarantula hawk, a large parasitic wasp, and what it does is grim beyond the spider's own hunting. When a female wasp finds a tarantula, she attacks it, and her sting delivers a paralyzing venom that does not kill the spider but freezes it, leaving it alive, aware, and utterly unable to move. Then she drags the paralyzed giant to a burrow, lays a single egg on its body, and seals it in. When the egg hatches, the wasp larva feeds on the living, helpless spider, from the outside in, kept alive as long as possible, so the meat stays fresh, consumed slowly over days, until nothing usable remains. Hold the horror of that against everything we have feared about the tarantula. The giant that paralyzes frogs and liquefies mice meets in the tarantula hawk, a predator that does to it something worse than anything it does to its own prey. turning the hunter into a living larder, paralyzed and devoured alive in the dark. If the tarantula is a monster, then nature has built a monster's monster to hunt it. And the spider, for all its fangs, has no real defense against the wasp at all. Now the threats turn from the natural to the human, and they begin with something that looks like admiration. Tarantulas have become hugely popular in the global pet trade, wanted, kept, bought and sold around the world, precisely because they are large, striking, long-lived, and in many species, breathtakingly beautiful. The vivid blues and jeweled patterns that puzzle scientists are exactly what drive demand among collectors, and the rarer and more gorgeous a species, the more intensely it is sought. There is real irony and real danger folded into that desire. The same beauty and fascination that might make us want to protect these animals also make them commodities and the most coveted species. The brilliantly colored rarities with tiny natural ranges are often the ones least able to withstand the pressure of being collected. Demand becomes a force of its own, reaching out from living rooms and online marketplaces across the world into specific small patches of forest where a prized species clings to existence. The tarantula's allure, the thing that should be its salvation, becomes instead a market, and the market, hungry for the rarest and most beautiful, presses hardest on exactly the animals that can least afford it. We have turned wonder into want, and want for some of these spiders into a threat, because that demand reaches straight into the wild. Many tarantulas sold to collectors are not bred in captivity, but taken directly from their habitats, dug out of their burrows, and pulled from their forests to be shipped across the world. For species with naturally small ranges and slow life cycles, this wild collection can be devastating, stripping animals from the very places they are rarest faster than they can possibly be replaced. Some of the most beautiful and sought-after species are also among the most narrowly distributed, found in a single forest or region, and concentrated collecting from those few places can hollow out a wild population with frightening speed. Conservationists have flagged the trade as a serious and poorly regulated risk, with monitoring and protections lagging far behind the booming online market. Picture what that means on the ground: a prized jewel-colored tarantula found nowhere else on Earth but one shrinking patch of forest, being lifted burrow by burrow and sent away to enclosures around the globe, until the forest that made it falls quiet. The animal that survived 100 million years, that outlasted the dinosaurs and rode the continents apart, can be emptied out of its last refuge in a few short years, not by any natural predator, but by the reach of human desire for a buy. Beautiful thing. And the deepest cruelty of that pressure lies in the spider's own slow biology. The very longevity we marveled at becomes its vulnerability. A tarantula species that takes years to reach maturity, that breeds slowly, that lives its long life at the patient tempo we admired, simply cannot replace its numbers quickly. Remove the adults from a wild population, and the gap they leave is not filled in a season or two. It takes many years for slow-growing young to mature and begin breeding, and during all that time the population stays thin and exposed. The same unhurried life that lets a female reign in her burrow for 30 years means that a damaged population recovers at an agonizing crawl, if it recovers at all. The traits that make the tarantula such a marvel of endurance on the scale of a single life become, on the scale of a whole species under pressure, a fatal slowness. A fast-breeding animal can bounce back from heavy losses. The tarantula cannot. It was built to outlast drought and famine and the slow turning of eras, but not to outpace a sudden, sustained harvest by the one predator that collects faster than the spider can possibly replenish. Its great gift, longevity, offers no protection here. Against the speed of human demand, the patient animal has no patience left to spare. Even where collectors never reach, the ground itself is being taken. Habitat loss presses on tarantulas across the warm world. The forests cleared, the grasslands turned to farmland, the specific patches of soil. A species depends on paved or ploughed or burned. For an animal so bound to one place, so faithful to a single burrow and a narrow range, the disappearance of that place is the disappearance of the animal. Many of the most striking species occupy tiny natural ranges to begin with, a single forest, a single region, and when that ground goes, there is nowhere else for them to be. The slow-breeding, slow-moving tarantula cannot simply relocate to better country. It is tied by its whole patient biology to the home it has. So the steady erosion of wild land does not just crowd these animals. For the narrowly distributed ones, it erases them quietly without malice, one cleared hillside at a time. The giant that survived 100 million years of natural upheaval that outlasted the asteroid and rode the continents apart meets in the simple loss of its habitat, a threat it has no answer for. It can endure drought and flood and famine. It cannot endure the vanishing of the very ground beneath it. And the cruelest possibility in all of this is that we are losing tarantulas we have never even met. Remember that the catalogue is still growing, that new species are described every year, that there are certainly tarantulas alive right now, with no name and no entry in any book. Put that together with habitat loss and the trade, and the conclusion is stark. Some species are very likely going extinct before science ever finds them, vanishing from a cleared forest or a collected range, while still entirely unknown, blinking out without ever having been recorded, named, or understood. We will never know what we lost because we never knew it was there. Hold the strange grief of that. Not the extinction of a famous animal mourned around the world, but the silent disappearance of creatures that existed, that hunted and molted and guarded their eggs in the dark for 100 million years of lineage, and then were gone before a single human eye ever catalogued them. Somewhere in a shrinking patch of forest tonight, there may be a tarantula unlike any we have described, living out its long, patient life, and the race between our discovery and its disappearance is one we are in places quietly losing. The book of these animals may be closing on pages we never got to read, yet the same venom we fear may turn out to be one of the spider's great gifts to us. Inside tarantula venom, alongside the chemistry that subdues prey, are peptides, small proteins that act with exquisite precision on the nervous system, and researchers around the world are studying them as the basis for an entirely new kind of painkiller. The reason is urgent. The venom contains molecules that can block the specific channels through which the body transmits pain, and scientists hope to engineer from them a drug as powerful as an opioid, but without the tolerance and addiction that make opioids so devastating. Teams working with species like the Peruvian green velvet tarantula and the Chinese bird spider have isolated promising peptides and are reshaping them molecule by molecule toward a treatment that could help the tens of millions of people living with chronic pain. The work is difficult and far from finished, but the promise is real. The very thing that makes the spider's bite hurt, refined and redirected, might one day be the thing that takes human pain away. There is a deep and fitting irony in it, the feared venom of the feared giant, hunted in the dark, holding in its chemistry a possible mercy for our own suffering, a gift hidden all this time inside the weapon. And the silk holds promises of its own. Spider silk is among the most remarkable materials in the natural world, extraordinarily strong for its weight, flexible and biologically compatible with living tissue, and researchers studying it see possibilities that reach far beyond the past. Burrow, silk, and silk-inspired materials are being explored for regenerative medicine and tissue engineering, valued for their strength, their biodegradability, and the way the body can tolerate them. The tarantula spins as a matter of daily living, a fiber whose properties human material science still struggles to match, manufactured at body temperature from simple ingredients, with a precision our factories cannot easily replicate. To learn its secrets fully would be to learn how to make materials we badly want, strong, light, healable, kind to living flesh. So the spider we recoil from is quietly a kind of master engineer, carrying in its body a manufacturing process we are still trying to understand, let alone reproduce. The silk that lines its dark burrow, that wraps its eggs and wires its triplines, may hold lessons that outlast every fear we ever attached to the animal that spins it. Another gift folded into the creature, waiting in plain sight, in the thread it has been drawing from its own body unbothered for 100 million years. So where did all our fear actually come from? It is worth asking plainly, because the dread we began with turns out to rest on remarkably little. The tarantula has never killed a person. Its venom to us is mostly a wasp's sting. Its strongest instinct is to flee, to hide, to warn before it ever bites. And yet it sits near the center of human nightmare, a fixture of our oldest fears. Part of the answer is deep and ancient, that hardwired primate wariness of spiders, sharpened over millions of years, when caution towards small venomous things genuinely paid. But part of it is something we did to ourselves more recently and more deliberately, a fear taught and amplified, layered onto the animal by story and image, until the creature itself disappeared behind the monster we made of it. The size and the hair and the fangs gave us the raw material, and we built the rest, assigning to a shy, patient, harmless giant a menace it does not possess and has never earned. The fear, in other words, is largely our own creation, projected onto an animal that wants nothing from us. And to see that clearly is to begin to see the tarantula at last, not as the nightmare we inherited, but as the creature it actually is. Much of that invented terror came from a single source, the screen. Film and folklore took the tarantula and made it a monster, the giant spider of horror movies, the lurking killer of legend, the eight-legged death that drops from the ceiling in 1,000 nightmares and 100 films. Over and over on screen and in story, the tarantula was cast as menace, its image bent toward dread until the performance replaced the animal entirely in the public mind. The real spider, patient, shy, harmless to us, a devoted mother and a quiet pest controller, could not compete with the monster because almost no one ever met the real spider. They met the myth instead, the slow-motion horror crawling across the screen, and they carried that myth home as if it were the truth. There is a real cost in that, a whole animal, ancient and gentle and extraordinary, reduced in the human imagination to a prop for fear, its actual nature buried under generations of invented menace. We did not just misunderstand the tarantula. We rewrote it, recast a living wonder as a villain, and then feared the villain we had written. The gentle giant of the dark has spent a century playing a monster it never was, in a story it never asked to be in. The plainest rebuttal to all of it comes from the people who actually handle them. Across the world, keepers hold tarantulas in their hands. Many species, especially the New World giants, are docile enough to be handled with care, far more inclined to sit calmly or amble away than to bite. These are not daredevils wrestling monsters. They are ordinary people who have learned what the animal actually is, a generally gentle creature whose first response to a human is almost never aggression. The cautions that remain are real but modest, the urticating hairs to keep from your face the more defensive old-world species, to respect the simple fragility of an animal that can be badly hurt by a fall. But the core truth cuts straight against the myth. The giant spider of nightmare will in most species rest quietly on an open palm. Picture that against everything the movies taught you, not a lunging horror, but a calm, deliberate animal stepping slowly across a human hand, wanting only to be left in peace. The people who know tarantulas best are not the ones who fear them most. They are the ones who have discovered hand to leg that the monster was never there at all. In some places, people have gone further still, they eat them. In parts of the world, tarantulas are food and folk medicine, both in Cambodia. Fried tarantulas are a known dish eaten in some communities to ease respiratory ailments. In parts of Brazil and beyond, various tarantulas have featured in traditional remedies for asthma and other complaints. The Goliath bird-eater itself is described as an edible spider, prepared and eaten where it lives. There is something clarifying in that fact. For all the terror the West has wrapped around the tarantula, there are cultures that look at the same animal and see a meal, a medicine, a perfectly ordinary part of the living world to be used like any other. The monster of one people's nightmares is another people's dinner, roasted over a fire without a second thought. It is a reminder that the dread we attach to this creature is not universal, not inevitable, not written into the animal itself, but a particular story told by particular cultures, one that other people simply never learned. The tarantula does not carry its menace inside it. We assign that menace or we don't, and where it isn't assigned, the giant of the dark is just another creature sharing the world, formidable, useful, and entirely real. And for all we have learned, the animal still keeps its secrets. There is a great deal about tarantulas that science genuinely does not yet understand, how exactly a near-blind spider navigates back to a burrow it can barely see, how much it truly learns and remembers across its long life, how its tiny nervous system assembles a working map of the world, from vibration and chemistry and touch. The mind of the tarantula, if we can call it that, remains largely a mystery, a pinhead of neurons performing feats of patience, recognition, and precision we cannot fully explain. Researchers are still working out the basic biology of many species, still describing behaviors, still puzzling over questions as simple sounding as how the animal finds its way home. Sit with how much remains unknown about a creature this familiar. We have feared the tarantula for centuries, kept it, filmed it, eaten it, and we still cannot say with confidence how it thinks, how it remembers, how it knows what it knows. The giant of the dark is not a solved animal. It is a standing set of open questions walking the forest floor on 8 legs, carrying inside its small ancient body a way of perceiving the world that we have only begun to understand. Even the venom we hope to turn into medicine guards mysteries we have not cracked. Tarantula venom is staggeringly complex, a chemical library of many distinct compounds, most of them never studied, each potentially acting on the nervous system in its own precise way. Spider venoms together are conservatively estimated to hold many millions of bioactive peptides, a pharmacological treasure we have barely begun to open. For every promising pain-blocking molecule, researchers have isolated. There are countless others in tarantula venom whose effects are entirely unknown, compounds that might hold the key to other treatments or reveal new things about how nerves and pain and signaling work or do something we cannot yet imagine. The bite we feared, it turns out, is also one of the least explored medicine chests in nature, and we have only just lifted the lid. There may be answers in there to questions we have not even thought to ask, cures, tools, insights hidden in the chemistry of an animal we spent centuries simply trying to avoid. The venom does not only threaten, and it does not only promise relief. It holds still, a vast unread store of possibility, locked in the glands behind the fangs of a creature we are only now learning to look at clearly. And so we end where the fear began, but seeing it differently now. The old hunter is still out there in the wet dark of the rainforest, in the dry burrows of the savanna, in the trees and the soil across most of the warm surface of the earth, waiting tonight exactly as its kind has waited for 100 million years. It is waiting at this very moment, motionless at the mouth of a burrow somewhere. A creature older than the dinosaurs, a patient giant that has outlasted asteroids and ice and the drifting of the continents themselves. We have spent this whole journey learning what it truly is, not the monster of our nightmares, but a shy and ancient survivor, a devoted mother, a quiet keeper of the insect world, a maker of silk and a holder of secrets, gentle in our hands and harmless to our lives, carrying in its venom a possible mercy, and in its biology 100 unanswered questions. And it is in places slipping away, pulled from its burrows, pressed from its forests, vanishing in spots before we have even given it a name. So the thought to close on is not fear, but something quieter and heavier than fear. This animal asked nothing of us but to be left in the dark, to wait as it has always waited. What we choose to do now, whether we let the old hunter keep its place in the world or take that place from it before we have even finished learning what it is not the spider's question to answer. It is ours. And the giant in the dark, patient as ever, is still out there tonight waiting to see what we decide.